Hey, I have a pretty difficult looking integral here on the board. We have some exponential functions, but it's not quite clear what to do. So now we can notice a few things. What we would like, imagine one thing that would make this really easy is if, let's say, instead of this being a 2, if that was 24. Because if it was 24, we could factor out a -4, and then we would just have 1 for an integral. So it would simplify very nicely. But that's not the case. Another thing we want to, so I think the second thing we want, it'd be nice if this could be our u and we could do a u substitution. Let's just look at what's going to happen if we make, let's just kind of try that. Like we'll call u equal to e minus 4x plus 6e to the x. And then our du is going to be minus 4. Good, that matches this. U to the minus 4x plus 6e to the x. We don't match the second part. So we'd really like our du to be this numerator, but it's not. We could force it to be that, but then I think we're going to have other problems. So I think what we need to do is combine both the original strategies where we'd like this to be 1 and we'd like to use a u substitution. And so what I'm going to do is so what we've done here is we've kind of made it happen where you'll notice in our first integral here, our numerator and denominator is the same. So this is just 1. Okay, so that's really nice. And then in our second integral, we've already done our u substitution. We're saying this is our u, and this is our du we want. And so the only thing that we need though is I put these constants in front. So when we add this whole thing together, we have to get back to our original integral or else we've changed the whole problem. So then we can set up a system of equations, multiply this through, and just make sure that this works where we find an a and a b so that our system is going to make sense. So now we've set up our system. Notice we multiply like our a in here to get this a. And so we need all of our coefficients on the e to the minus 4x terms have to equal our original minus 4. And then similarly with our e to the x terms, we have like minus 6a plus, just 6a, 6b is going to equal our minus 2. And so we just need this system to work. So we can just solve a system of 2 equations, 2 unknowns, but then we can take out we don't, at this point, because you'll notice in each equation, it's just we have the same e to the minus 4x, so we can just solve for our a's and b's. So now what we've done is we've reduced this thing to here is our system. We just have this like very simple algebra problem that you would do in like your first algebra class. And so we can solve this. You can solve it anyway, substitution or adding the equations together. But what we'll do is we'll skip the details in that and let's just skip to the answer. So for our a value, we're going to have minus 16 over 15. And for our b value, we're going to have 11/15. Then going back to our original integral, we've plugged in our a value here and our b value. And then we canceled out, remember, so we canceled out our first integral to get a 1. And we made our substitution to have du over u. So this is actually really simple integrals now to get to the solution. We're going to end up with minus 16 over 15x plus 11 over 15 ln absolute value of u plus c. And then we just need to go back and see what our u value was. This piece right here. Then our final solution is going to be minus 16/15 x plus 11 over 15 ln absolute value e to the minus 4x plus 6e to the x plus c. And we're done. Got this problem from my quiz, Kramer's rule integrals. Provide a link in the description. Thanks for watching. Have a good day.